You've seen them, those giant curved structures towering over power plants often mistaken for chimneys. But here's the thing, they're not smokestacks. And that white cloud, it's not smoke. So what are they? Why do they have that distinct hourglass shape? And what do they actually do? In today's video, we're diving deep into the engineering behind cooling towers, why they're shaped the way they are, how they work, and the science that keeps our power plants running efficiently. Stick around because this is about to get fascinating. Don't forget to like, comment, and subscribe if you love learning about the structures that shape our world. And if you'd like to support the channel, check out the link in the description below. A cooling tower is essentially a giant heat exchanger. Its purpose? To remove excess heat from industrial processes, whether that's from a nuclear power plant, a coal-fired plant, or even large-scale HVAC systems in big buildings. And no, that white cloud billowing out isn't smoke, it's just water vapor, like the steam from your kettle. The cooling tower's job is simple but crucial. Cool down water that's been heated during power generation so it can be reused in the system, efficient, sustainable, and surprisingly complex. Here's how it works. Hot water from the plant is pumped to the top of the cooling tower and distributed over what's called the fill. The fill is designed to spread the water out, increasing its surface area so more of it can come into contact with air. As the water trickles down, fresh air is drawn in from the bottom. This happens through a process called natural draft. Warm air rises because it's less dense, pulling cooler air in from below. As the water meets the air, some of it evaporates, which removes heat from the rest of the water. That's why you see that big cloud. It's just evaporated water. This entire process relies on basic principles of heat transfer, moving heat from hot water to cooler air. It's incredibly efficient, especially considering that the air does all the work without mechanical fans in most cases. Now the big question, why are cooling towers shaped like this? The answer lies in both aerodynamics and structural engineering. That curved hourglass design is called a hyperboloid. It's not just for aesthetics. This shape is incredibly efficient for airflow. The wide base allows large volumes of cool air to enter. As the air rises through the narrowing center, it speeds up, creating a powerful natural draft without any fans. Then, as the shape widens again near the top, it reduces air resistance, letting the warm, moist air exit smoothly. But it's not just about airflow. The hyperboloid structure is also incredibly strong. It distributes vertical loads and handles wind stresses efficiently, which is crucial because these towers can be over 200 meters tall and face extreme weather conditions. The design uses less material while maintaining strength, which means cost savings during construction. It's a perfect blend of form and function, engineered to be both strong and efficient. So what are these massive structures made of? Most cooling towers, especially the large natural draft ones, are built with reinforced concrete. Concrete is durable, strong, and resistant to temperature changes, which is important when you've got hot water and cool air interacting constantly. Construction often uses a method called slip forming. This involves continuously pouring concrete while the formwork moves upward. It's a bit like a three-dimensional printer for concrete, allowing the tower to be built quickly and without structural weak points. The result? A solid, seamless shell that can last 40 to 50 years with minimal maintenance. Not all cooling towers are created equal. The ones you're probably familiar with, those giant hyperboloid structures, are called natural draft cooling towers. They rely entirely on natural airflow to do the cooling. But there are also mechanical draft towers, which use large fans to force air through the system. These are common in smaller industrial setups, or in places where natural airflow isn't enough. Some even use closed-circuit designs where water flows through pipes instead of mixing directly with air, perfect for areas where water conservation is critical. Some of the most recognizable cooling towers are at places like 3 Mile Island in the US, Didcot Power Station in the UK, and Tihange Nuclear Power Plant in Belgium. They've become landmarks in their own right, even though they were designed purely for function. Environmentally, while cooling towers don't release pollutants, they do affect local humidity levels and can create plume clouds which can even influence local weather patterns. That's why engineers carefully consider tower placement, local wind conditions, and water usage to minimize environmental impacts. So, next time you see one of these massive towers, you'll know it's not just a giant chimney. It's an engineering solution designed for efficiency, sustainability, and structural strength. What do you think? Did you learn something new today? Let me know in the comments below. And if you enjoyed this video, don't forget to like, subscribe, and hit that notification bell. Plus, if you'd like to support the channel, check out the link in the description. Thanks for watching.